I know we're in a really weird time right now where we're not all in the same room. But if you don't work with me back and I never see your presentation, it will result in a penalty. So that's proposal assignment 4. Like I said, the assignment sheet is up, and there's also this example from Dr. L here. But what we're going to go over now is developing and graphing your hypotheses. So this is a big part of your proposal paper and of this presentation. So a big part of the proposal papers and the presentation is your hypotheses, as I said. The next part of the lab goes directly with the Lab 11 worksheet, which again is uploaded on Canvas, and I'll show you in a second. And the worksheet will help you develop and graph your hypotheses, thus jump-starting you in your presentation. So this is what the worksheet looks like. Again, it's uploaded to Canvas. We're going to go over all of these right now, but this is a large part of your presentation. So if you do this worksheet, you should have a huge start on your presentation, and it should be relatively painless to get your presentation together. So let's go over this step by step. Step 1 is to write the 3 variables you plan to use in your study and identify them as continuous or discrete. So this depends on what kind of study design you're doing, if you're doing a correlational study or if you're doing an experimental study. So correlational study, your variables are a predictor, your outcome, and your moderator. You must have a continuous predictor and outcome, and your moderator can either be continuous or discrete. So again, your continuous predictor and outcome and a moderator can either be continuous or discrete. For experimental studies, you have one independent variable, a second independent variable, and a dependent variable. Your independent variables must be discrete, and your dependent variables must be continuous. That's very important. Please keep that in mind. I don't want to mark points off for having the wrong kind of variable. So your second step is to create a conceptual diagram depicting your 3 variables. So I'll give an example right here. An experimental study with gender of the participant as your IV, which is discrete, either man or woman, the gender of the job applicant as IV2, discrete, man or woman, and hiring potential as your DV, which is continuous. So we'll say hiring potential is a scale of like 1 to 5 for how hireable do you think the person is. So if I created a conceptual diagram of this, what color is my pen? Yeah, sure, red's fine. I would have IV1, which is gender of participant here. So gender here. And leading to my dependent variable, which is hiring potential. I'm just going to write hiring to save time and spare you my handwriting. Hiring. And then our moderator is up here, and my moderator would be the second independent variable, and that would be gender of job applicant. So gender of job applicant. And that's our moderator. Moderator influences the relationship between gender and hiring. So that's an example of a conceptual diagram depicting your 3 variables. Just an example of one, I just want to show you where to fill in which variables. Your dependent variable is always going to go on this circle on the right, and then your 2 independent variables go here and here, or in the case of a correlational design, your predictor would go here and your moderator would go here. So sorry for this weird effects. Here's some more conceptual diagram examples. So this is the one that I just drew, IV1, IV2, dependent variable. So IV1 has a relationship with the dependent variable, IV2 affects this relationship, and then IV2 also depicts the dependent variable. And then this is an example of a correlation design, so predictor, outcome, moderator. It's pretty much the same thing, just a little bit of switching of the terms. So third, you want to write your 3 alternative and directional hypotheses. This is going to be the trickiest and the most important part. So I want you all to remember that you have 3 potential effects, which means you need 3 hypotheses. So main effect 1, main effect 2, and your interaction. So let's start with correlational studies. For main effect 1, you need to answer how your IV1 relates to your DV. For main effect 2, you need to answer how does your IV2 relate to your DV, or fill this in with predictor and moderator. You need to describe the direction, so positive, negative, or no relationship, and the strength of the relationship, weak, moderate, or strong. So you can't simply just say that there's a significant relationship. You need to describe the direction and the strength of it as well. For the interaction, with a correlational design, you have to predict a significant interaction and then explain the nature of the interaction. So again, not just enough to say it's significant, you need to describe what that means. An easy way to do that is to follow this format right here. So for level A of your moderator, what is the relationship between your predictor and outcome, the significance, direction, and strength? And then for level B of your moderator, what is the relationship between the predictor and outcome? Let's do a quick example. So here's an example. We have a correlational study with alcohol consumption, a predictor 1 to 5, so how much alcohol someone drinks in a week. Depression, which is our moderator, a 1 to 5, how depressed they are. And then happiness, how happy they are, our dependent variable, again, 1 to 5. So here's our hypotheses. Main effect 1. I'm predicting that alcohol will be strongly negatively related to happiness. As alcohol rises, happiness decreases. So I'm predicting a negative relationship, that's the direction, and a strong one, that's the strength, related to happiness, which means that as alcohol goes up, happiness goes down. Main effect 2. Depression will be strongly negatively related to happiness. Again, we have strength, strongly, and relationship and direction, negatively. As depression rises, happiness decreases. And then here's our interaction. There will be a significant interaction between depression and alcohol. The effect of alcohol on happiness will depend on depression. So that's the first sentence. That's just stating that will be an interaction. Secondly, we have to describe what that means. So when there is high depression, that's our moderator, there is a strong negative relationship between alcohol and happiness. So when depression is high, the relationship between alcohol and happiness is negative. So high depression, when someone is very depressed, it means that the more they drink, the less happy they are. However, when there is low depression, there's no relationship between alcohol and happiness. So this means that the effect of alcohol consumption on happiness depends on depression. Because when someone is really depressed, more alcohol makes them less happy, but when someone is not depressed, there's no relationship between those two. So this is directly from this template right here. For level A of your moderator, what is the relationship between your predictor and your outcome? If we switch, level A is high depression. When there's high depression, the relationship is a strong negative relationship between alcohol and happiness. Going back, for level B of your moderator, what is the relationship? Level B is low depression. There is no relationship between alcohol and happiness. So going to an experimental study, developing our hypotheses. For a significant hypothesis, you're describing differences between means for an experimental study. So you need to talk about what level of the IV will score higher or lower on the DV compared to the other level of that IV. Again, an example is coming, so stay tuned. Don't use correlational terms. For experiments only, if you graph out your data and your lines do not cross, then you do not have to predict a significant interaction. So for experiments, you don't have to predict an interaction. For correlational studies, you do. So only describe a significant interaction for experiments if it makes sense that the lines in your figure would cross. If you don't think there's going to be an interaction, then you don't have to predict one. For describing a significant interaction, you need to describe the nature of it. This is back to the example we did last week with tasty or not tasty food and portion size. So for example, here's how you can describe an interaction. For tasty food, people with larger portions will report higher satisfaction than small portions. For not tasty food, people with small portions will have higher satisfaction than large portions. Now let's graph out our hypotheses just like we did with the correlational study. So here's an example. Tastiness of food so it's two levels, either tasty or not, and that's independent variable 1. Portion of food, either small or big, which is independent variable 2, and then satisfaction, which is our dependent variable. So main effect 1, I'm saying there will be a main effect of tastiness on satisfaction. The tasty food will have higher satisfaction than the not tasty food. Do you see how I'm showing that one level of the IV will be higher than the other? So the tasty food will be higher than the not tasty food. So tasty versus not tasty, one is higher in satisfaction than the other. Then we have main effect 2. There will be a main effect of portion on satisfaction. The big food, so the large amount of food, will have a higher satisfaction than the small food. Again, comparing the two levels of the IV. And then lastly, for the interaction, this is the exact thing copied from the last slide. For tasty food, people with larger portions will report higher satisfaction than small portions. For not tasty food, people with small portions will have higher satisfaction than large portions. The next step would be to graph your hypotheses. We're going to use that last example with food to show you how to graph something. So the steps. First, you're going to draw a vertical axis labeled with the outcome dependent variable. Where's my pen? So vertical axis with the outcome. So this is satisfaction from the last example. Satisfaction. Second, you have a horizontal axis labeled with one of your independent variables or predictor variables. I'm going to do tasty versus not here. Tasty versus not. Third, you have a legend containing a coding system that distinguishes the groupings. So our second variable is small or big portions. So I'll do this is small. And again, so sorry for my handwriting. And then a box filled in will be big. And then finally, you draw best fitting lines, or the cell means connected by lines. I'm going to show you how I do this, the easiest way for me to conceptualize this. So we don't have actual numbers to go with, but it helps me to at least make up numbers so I can graph them. So just like we did with in lab assignment 7 last week, okay. So let's make a chart or with data just like we did last week, or we were presenting with last week. So let's say we have our two groups here. We have small, and we also have big, and then we have tasty and not. So let's draw a chart here. Okay, so if I'm thinking this through, I predicted that tasty there'd be a main effect of taste such that tasty would have higher satisfaction than not, and also a main effect of portion size such that small would have higher satisfaction than big. Is that what I hypothesized? Big will have a higher satisfaction than small. So I'm actually going to switch that because that's not what I hypothesized. Small and big. Okay, so here's how I like to do this. Let me draw my grouping again. So this is small, S for small, B for big, T for tasty, and N for not tasty, or NT for not tasty. So I think that if somebody has tasty food, but it's a small portion, maybe they will be an 8 on satisfaction if our scale is 1 to 10. Again, these are just made up numbers. This is just to help you. Let's see if they have a big meal and it's tasty, they'd have a 10. So a small meal that's not tasty, maybe they're going to score like a 6. And a big meal that's not tasty, maybe they're going to score like a 2. Now again, these numbers have to line up with your hypotheses. So to check your hypotheses, we look at our marginal means. So let's see. Our marginal mean of tasty would be 10 plus 8, which is 18, divided by 2, which is 9. And then 6 plus 2 is 8 divided by 2, which is 4. Sorry, I did the math wrong on my own sheet. That's why I'm laughing. So that main effect would work out because tasty is better than not tasty, 9 versus 4. Let's look at small versus big. 8 plus 6, 8, 9, 10, 11, 12, 13, 14, divided by 2 is 7. And then 10 plus 2 is 12, divided by 2 is 6. So we have small has more satisfaction than big, which is also what I hypothesized, I believe. So from there, we'll go ahead and graph this according to the steps. So let me change my pen color. We have our vertical axis, which is satisfaction. I'm just going to write an S on here for satisfaction. A horizontal axis, which has one of our independent variables. Let's do tasty and not tasty. And then our legend. So this is small. And then filled in is going to be big. So let's graph. So when we are a small portion size and tasty, so small.